Machine learning is awesome, except when it forces you to do advanced math. The tools for machine learning have gotten dramatically better, and training your own model has never been easier. We'll utilize our understanding of our dataset rather than an understanding of the raw mathematics to build a model that gets us insights. Welcome to Cloud AI Adventures. My name is Yufeng Guo. On this show, we'll explore the art, science, and tools of machine learning. While machine learning might be a great conversation topic at dinner parties, it's even more useful with code. In this episode, we're going to train a simple classifier using only a handful of lines of code. In fact, here's all the code that we'll look at today. To train our classifier, we'll use TensorFlow, Google's open source machine learning library. TensorFlow has a pretty large API surface, but the part we care about today is just the high-level APIs, called Estimators. Estimators package up the training loop for us so that we can train a model by configuring it rather than coding it by hand. This takes away much of the boilerplate, allowing us to think at a higher level of abstraction. And this means we'll get to play with the interesting parts of machine learning and not get too bogged down in the details. Since we've only covered linear models so far in this series, we'll stick with that here and revisit this example in the future to extend its capabilities. So with that, let's dive right in and go to our Jupyter Notebook. Okay, so here we are in our Jupyter Notebook. And the first thing that we'll do is import TensorFlow as TF and NumPy as NP. I like to print out the version number of TensorFlow to confirm which version I'm using. This week, we'll be building a model to distinguish between 3 different types of very similar flowers. I realize that this may be less interesting than the beer and wine from the previous episode, but these flowers are a bit more difficult to distinguish, making this a more interesting challenge. In particular, we'll be classifying different species of iris flowers. Now, I'm not sure I could pick out an iris flower from a field of roses, but our model is aiming to distinguish Iris setsota, Iris versicolor, and Iris virginica. We have a data set of measurements of the height and width of these flowers' petals and sepals. These 4 columns will serve as our features. So let's load our dataset in using TensorFlow's load_CSV with header function. The data or features are presented as floating point numbers, and the label for each row of data or target is recorded as an integer, 0, 1, or 2, corresponding to our 3 species of flowers. Now, I've printed out the results of our loading, and we can see that we are now able to access the training data and the associated labels or targets using named attributes. Next, we'll build the model. To do this, we'll first set up the feature columns. Feature columns define the types of data coming into the model. We are using a 4-dimensional feature column to represent our features and calling them flower features. Building our model using estimators is super simple. Using tf.estimators.linearClassifier, we can instantiate the model by passing in the feature columns we just created, the number of different outputs that the model predicts, in this case 3, and a directory to store the model's training progress and the output files. This allows TensorFlow to pick up training later on from where it left off, if needed. This classifier object will keep track of state for us, and we are now almost ready to move on to the training. There is just one final piece to connect our model to the training data, and that is the input function. The job of the input function is to create the TensorFlow operations that generate data for the model. So we go from raw data to the input function, which passes that data, that is then mapped by the feature columns to go into the model. Notice that we use the same name for the features as we did in defining the feature column. This is how the data is associated. Now it's time to run our training. To train our model, we'll just run classifier.train with the input function passed in as an argument. This is how we connect our data set to the model. The train function handles the training loop and iterates over the dataset, improving its performance with each step. And just like that, we've completed 1,000 training steps. Our dataset is not huge, so this completed rather quickly. Now it's time to evaluate our results. We can do this using the same classifier object from before, as it holds the trained state of the model. To determine how good our model is, we run classifier.evaluate and pass in our test dataset. Then we can extract the accuracy from the metrics that are returned. 96.6%. Okay, let's pause here and review what we've achieved so far. The Estimators API has given us a nice workflow of getting our raw data and passing it through an input function, setting up our feature columns and model structure, running our training, and finally running our evaluation. This easy to understand framework allows us to think about our data and its properties rather than the underlying math, which is a great place to be. Today we looked at a very simple version of TensorFlow's high-level API using a canned estimator. In future episodes, we'll look at how to augment this model with more details, use more complex data, and add even more advanced features. Thanks for watching that episode of Cloud AI Adventures. You can catch the whole series here, and if you have any thoughts and comments, feel free to leave them down below.